In this lesson, the majority of our work will be spent finding trig values. For the first three examples, we're going to determine the exact values of the 6 trig functions of the angle theta. We'll notice that the presentation of the problem is that we have ordered pairs, not angles. But each of these ordered pairs, when plotted on a coordinate plane, will tell us what angle theta we're working with. So example 1. Consider the ordered pair -8, -15. From the origin, we would go left 8 and down 15. So left 8, down 15, here's our ordered pair, our point. All right, so what's the triangle that we need so we can find the 6 trig values? What we're going to do is we're going to plot the point, and then we're going to go back and connect to the origin. At this point, we're going to create a right triangle, but we always create our right triangles by taking our point and either bringing it up to the x-axis, never the y-axis, we never go over. We create the right triangle by taking the point and going up to the x-axis, or if we happen to be above the x-axis, we drop down to the x-axis. So just kind of a thing that we have to kind of know, that when you create that right triangle, it has to be created to the x-axis, either the positive or the negative. Right, so let me go ahead and complete this triangle. So we plotted the point, we connected to the origin, let's complete the right triangle. So here's our right angle. I'm going to label this side -8. I know the length of the leg of that triangle is +8, but the negative tells us what quadrant to go into. And then this side right here is going to have to be -15. So remember, -8 is x, and y is -15. All right, so now what we do know is from the positive x-axis all the way over here to the terminal side of this angle, this is our theta measure right here. So when they ask us to find the exact values of the 6 trig functions of the angle theta, and we're given an ordered pair, remember we want to label theta as going all the way over to that terminal ray. We're going to use this little acute angle in here. We sometimes call that theta prime. We'll see in a later lesson that theta prime is called the reference angle. This is going to help us get the answers to these questions. All right, so next thing we're going to do is we're going to use Pythagorean Theorem. So get your calculator out. -8 squared, -15 squared, those are the legs. Add, take the square root, and you're going to get 2 values, but you only want the positive one. So the length of this hypotenuse is 17. All right, so what's the sine of theta? Well, what we're going to do is we're going to think about theta prime being our assistance here. So we really just look at the relationships within this triangle, and we'll find sine of theta. So sine of theta is what? Opposite over hypotenuse. And from here, it should be kind of straightforward with all our previous practice of finding trig values. Let's just stop and make sure that this makes sense to us. The sine, which is y over r, remember 17 is r. Okay, the sine ratio is negative. Should it be negative? Yes, because I'm down in quadrant 3 and the y-coordinates are negative in quadrant 3. Now the hypotenuse will always be positive, but the 2 legs could either have a sign that are positive or negative depending upon what quadrant we're going into, depending upon what ordered pair is given. But we're always going to get a positive hypotenuse. So because the sine, which is y, is negative, it makes sense that my point should be down here in quadrant, well, at least quadrant 3 or 4. All right, same thing with cosine of theta. Think about the point, okay? You're in quadrant 3, 17 is always going to be positive, but cosine is connected to the x-coordinate, and it is negative because that's going to get me down here into quadrant 3. All right, what about the tangent of theta? Well, that's opposite over adjacent, so that's going to be -15 over -8, but I'm not going to bother writing down the 2 negatives. Does it make sense that the tangent ratio, which is x over y, or excuse me, y over x, does it make sense that that answer is positive? Yeah, because if I have 2 coordinates that are both negative and I divide, I'm going to get a positive number. So I would have to be in quadrant 3. Remember, this is quadrant 1, 2, 3, and 4. And then from here, the rest of our work is easy. We just reciprocate the previous 3 trig values and we're done. I could have put cosecant first. I don't know why I didn't. I'll go to cosecant theta. 17 over 15. And the secant of theta is going to be negative 17 over 8. I just moved that negative sign up to the 17. I'm not suggesting that 17 is negative. It's just kind of the placement of that negative in a fraction. All right, let's look at number 2. Determine the exact values of the 6 trig functions of the angle theta. I don't have an angle, but I do have an ordered pair. So I'm going to go left 1 and up 1, and I'll put my point right here. First, connect to the origin. That's going to create your hypotenuse, or sometimes called the radius. Complete the right triangle by dropping to the x-axis. Label all the sides with the appropriate signs. So remember, that's x and y. All right, at this point, I noticed that both the leg lengths are the same, 1 and 1. So this is a 45-45 right triangle, which means if I did Pythagorean Theorem, or if I just took the side length right here, multiply it by square root of 2, I would get square root of 2 as my radius. Now that we have all 3 sides value, we can find the 3 trig functions. So don't forget to put the theta here. Now remember, this is theta. It's an angle bigger than 90, just like theta was bigger here, but we'll use this little theta prime, which will be called the reference angle, to assist us in getting the ratios. So the sine of theta prime is going to be the same as sine of theta, just kind of a little technicality. So opposite over hypotenuse, or y over r for sine, you're going to want to rationalize. We've done a lot of work with that already, so we're going to get square root of 2 over 2. And think about that. That makes sense. If we're on the unit circle, the sine of a 45-degree angle is going to be the y-coordinate of square root of 2 over 2. Same thing here. So what's the tangent? Cosine of theta is adjacent over hypotenuse, so that would be negative because I am in quadrant 2. So cosine should be negative. The tangent is just going to be y over x, so that's just going to be negative 1. I'll just go ahead and continue with the cotangent. The reciprocal of negative 1 is negative 1. Cosecant of theta. I'm not going to reciprocate this form of the sine's value because that'll put a square root in the denominator. I'm going to come back here and reciprocate this form of sine of theta, and I'll get square root of 2. And secant of theta is going to be negative square root of 2. Okay, number 3. Let's plot the ordered pair, square root of 5, negative 2. So from the origin, square root of 5 is a little more than 2, so I'll just say this is square root of 5. It's positive. I'm going to drop down 2. I'll just say this is 2. So I put the point right here. Connect to the origin, create your right triangle. I'm going to move this negative 2 over here. Make sure and put the sign there. Let's do Pythagorean Theorem, and we're going to get a hypotenuse of 3. Make sure that you're involving the positive negative signs when you populate all the 6 trig values. I'm not going to go ahead and do that. I'll share my key with you at the end of this lesson so you can do those on your own. If you want to stop the video and try them now, great. Or if you're comfortable with what we're doing, that's fine too. You know, you don't need to worry about finishing them if you're comfortable. But if you need the extra practice, you know, if you do, then go ahead and complete that problem. All right, let's look at number 4. It's telling us that this point is on the terminal side of an angle in standard position. Well, this looks like the same type of problem we just did. Determine the exact values of the 6. It is exactly the same. We'll just go ahead and set up the triangle in the appropriate quadrant, and then we'll walk away from the trig values. You can do the same, but if you want the practice, you can do it, and I'll share the key in a minute. All right, this is x, this is y, so I'm going to go, right 5 and down 12. I might extend that a little bit. My ordered pair, connect to the origin. Remember, we're never going over and creating a right triangle to the y-axis. So bring that altitude up here. So go back and label the sides. So this is 5, this is negative 12. Pythagorean Theorem is going to get us 13 for the hypotenuse, which will always be positive. All right, and then over here you can find the 6 trig values. I don't think there's anything interesting here on this one. It's pretty straightforward. Okay, I'm going to come back and I'm going to do these 4 problems at the end of the video because these are the only 4 problems that have a different objective than finding the trig values. Down here, they want us to find the quadrant in which the angle lies. So we'll do these at the end of the video. Let's just continue finding trig values, okay, with maybe some different given information. All right, so the directions are find the values of the 6 trig functions of the angle theta. Okay, so what's given now? Well, we don't have an ordered pair like in the previous problems, but what they did tell me is that I already know that the cosine of theta is -4/5. Okay, well, that's not enough for me to find the remaining 5 trig values. So let me come over here and look at a constraint. Tells me that theta lies in quadrant 3. Okay, so over here, when you're given this information, a right triangle, not the unit circle, is going to assist you in getting the other 5 trig values. So let's go ahead and draw a coordinate plane. Theta lies in quadrant 3 down here. So I'm just going to choose an arbitrary point in quadrant 3. I'm going to create a right triangle. Remember, this whole thing is theta, but I'm going to use this reference angle called theta prime to label this triangle. So that's all I know from this constraint, that the angle lies in quadrant 3. But let's go back here and go, oh, well, the cosine of theta is going to be x over r. So let's look at this fraction. It's -4/5. Well, 5 can never be negative because it's the radius. So it must be the 4 is the negative, because remember, with the negative right here, you could either put it up top, down at the bottom, or out front. So it has to be that my x-coordinate is -4. So I'm going to come back and label. So I'm going to go left 4. Remember, 5 is going to be your hypotenuse. So now we're missing a leg. So let's do Pythagorean Theorem. Square 5, get 25. Subtract, instead of add, subtract 16. Get 9, square root. We're going to get 3. Now remember, we want the negative because we're in quadrant 3, and this is going to be the y-coordinate when we're in -3. So there's a little more detail you have to pay attention to here. So left 4, down 3, -4, -3. But the hypotenuse is always positive. All right, can we find the 6 trig values? Yes, we certainly can. We'll just do one of them here. Sine of theta. Oh, we've already got cosine, so I'm going to go right to tangent. Tangent, okay, well, that's going to give me a positive value because I'm in quadrant 3, so opposite over, so that's 3/4. I'll do cotangent, 4/3. I think I'm going to swing up here and do cosecant across from sine. So that's going to be -5/3. Secant theta. I have cosine, so I could have found secant theta right from the beginning without doing any work and gotten -5/4. All right. All right, same objective on number 10. We have to find the values of the 6 trig functions given this information. The best thing to do is draw a right triangle. So let's get a coordinate plane here. Let's see if we can look for clues as to where I'm going to put that right triangle in which of the 4 quadrants. All right, all I know is that cosecant of theta is 4. I'm going to make 4 a fraction by putting it over 1. Remember, cosecant is r over y. So it looks to me like the radius of this, or the hypotenuse of this right triangle, is going to be 4, and the y-coordinate is going to be +1. All right, well, if the y-coordinate is positive, that limits me to quadrant 1 or 2. So remember, cosecant being positive is like sine being positive, and sine is connected to the y-coordinate, and coordinates that are positive, y-coordinates that are positive, are going to not be down here because those will be negatives. But I still have to decide which of these 2 quadrants to draw my triangle in. So then I come over here and look at the constraint. Well, cotangent of theta, which is x over y, is negative. It's less than 0. Well, remember, we already know that y is positive. So what kind of x do I need so that when I divide, I get a negative answer? Well, x must have to be negative. So -x, positive y, tells me I'm going to be over here. So I'll just put an arbitrary point in quadrant 2, draw the hypotenuse, label it 4. Remember, this is r. I'm I'm going to drop down, draw my right triangle. The y-coordinate is 1, so this leg length is 1. Let's use Pythagorean Theorem. So 16 minus 1 is 15. So this leg length is 15, but remember I'm in quadrant 2, so I've got to go back and make that adjustment to a negative. All right, at this point I have cosecant, so I do have sine, which is 1/4, and then from there I would just find the other 4 trig values. All right, so the objective is the same in all these problems. It's just the presentation of the problem kind of changes. Sometimes you're given an ordered pair, sometimes you're given information, you know, about where that point is, and we have to be able to extract that and put the right triangle in the correct quadrant. All right, let's look at these middle sets of problems here and see what's changing. All right, the terminal side of theta lies on the given line in the specified quadrant, okay? Find the values of the 6 trig functions of theta by finding a point on the line. All right, so I've got this line. It tells me I want to consider this linear function in quadrant 1. Let me go ahead and draw a coordinate plane because I need that right triangle. We know how to plot y equals 1/3 x. There is no y-intercept. Well, the y-intercept is 0, so I start here. 1/3 is your slope, so that's rise over run. So I'm going to rise 1, and then after I go up 1, I'm going to run 3. So from the origin, I'll connect. I'll continue drawing this line that they're mentioning here. If I were to plot y equals 1/3 x, that line would look like this. And notice that line goes through quadrants 1 and 3. So unless they told me what quadrant to work in, I wouldn't know how to draw my right triangle, but now I do. So I went up 1 and over 3. Okay, so I'm going to draw my right triangle. My right angle, this is 3. I'll go ahead and label this side as 1 because that's my height. So that tells me I've got to do Pythagorean Theorem. That'll give me square root of 10 from this point to the origin. From here, let's calculate all the 6 trig values. Again, I'll let you guys do that. I'll share the key with you at the end of the video. All right, let's look at 12. We want to graph this line. Even if we used our calculator, it's not calculator ready, we would have to solve for y. So let's go ahead and get this equation solved for y. And let's see if we can avoid using a calculator and just use our own knowledge of how to graph this function. All right, so let's get this equation solved for y. So I'm going to subtract a 4x. So 3y equals negative 4x. Oh, easy as can be. Divide by 3. All right, let's plot y equals negative 4/3 x, and we're going to want that part of the line that falls in quadrant 4. All right, I'm going to start at the origin. This is rise over run. So I'm going to drop 4 and run 3. So I'm going to drop 4 and run over 3. I'll put the point right here. So if I'm going to sketch this complete line, it would go through quadrants 2 and 4, but they told me I want quadrant 4, so now I know where to draw the triangle. So I've got this point here. I'm going to draw the right triangle. Let me get the sides labeled. So this is where I'd put the 3. And I dropped 4, so this would be negative 4. Remember, right 3, down 4. Pythagorean Theorem would give us a radius of 5. Okay, so remember, this is the angle we're talking about. That would be called theta, but we're really using this theta prime reference angle inside this triangle to help us get the trig values. So the trig values of theta and theta prime will be the same. Okay, we'll do these last few problems here and then we'll return to the front. All right, evaluate the trig function of the quadrant angle if possible. All right, cosecant of 3 pi over 2. Now we're kind of moving out of the right triangle perspective. Where do I know 3 pi over 2 is? Well, I'm going to draw a little coordinate plane. I know 3 pi over 2 is down here. Let me think about the unit circle. And knowing that that ordered pair is 0, -1, I would label this x and y. I think about the cosecant on the unit circle at 3 pi over 2. That's going to be equivalent to 1 over sine of 3 pi over 2. So a couple ways to think about it. You can do it this way, or you can just straight go to the y-coordinate, which is sine, and find its reciprocal. When you reciprocate -1, like make it a fraction, put it over 1, but then flip it, the cosecant of 3 pi over 2 is going to be -1. So this is equal to -1. All right, what's the cotangent at 3 pi over 2? Well, I've got that angle drawn here. Let me think about what cotangent is. I'm thinking about the unit circle, not the right triangles anymore. Sometimes right triangles, assist us in finding trig values, but sometimes we want to be able to go back to the unit circle. So it's good to be able to know that you have the availability of the unit circle or a right triangle depending upon what's given to you in the problem. All right, cotangent is x over y. So I've got the x, the y, build a fraction. This is 0 over -1. But remember, you might as well just simplify that to 0. 0 over any number besides 0 is going to be 0. All right, secant of 0 radians. Remember, this is the angle. So 0 radians on the unit circle would be you've never lifted off the positive x-axis. So think about the unit circle. If I drew it, this would be the point 1, 0. This is x, this is y. Secant is the reciprocal of the x-coordinate. So 1 over 1, flip it, you're still going to get 1. All right, what's the cotangent of pi? All right, unit circle. Remember, pi is over here. Unit circle, that ordered pair would be -1, 0. That's x, that's y. Cotangent is -1 over 0. We would want to go ahead and further state that that's undefined or does not exist. Cosecant of pi over 2. Pi over 2 is up here on the unit circle. That's the ordered pair 0, 1. Cosecant is the reciprocal of sine. So sine is y. So this is x, this is y. So that's just going to be 1. All right, so basically these last ones involved our knowledge of the unit circle, made it a little bit easier than drawing a right triangle. The majority of our other work was creating a right triangle based on the given conditions, and then using Pythagorean Theorem to find the missing side of that right triangle, and then setting up the 6 trig ratios. All right, let's go back to the front and finish those last problems at the bottom, and then, like I said, I'll share the key if you're interested in completing the other problems. All right, for this last objective, we're asked to state the quadrant in which theta lies. So in problem 5, they told us that the sine of theta, some angle, is positive, and the cosine of some angle is negative. So greater than 0, less than 0, I just use the words greater than 0 meaning positive. Another way to think about that is above the x-axis. Less than 0 is the words negative, or below the x-axis. So state the quadrant in which theta lies. So let's do this. Draw a coordinate plane for all 4 of these problems. Using the given information, we're going to be able to narrow down from 4 down to 1 quadrant in which this angle theta lies. So for this same angle theta, the sine has got to be positive. Now, sine is y, of course, over r, but r is always positive, so let's just look at sine. So where is y positive? Well, the y-coordinates of any points are positive in quadrants 1 and 2, not down here, so we rule these out. So now of the 2 remaining quadrants, okay, which quadrant does our angle lie in? Well, the other condition is that the cosine of the angle is negative. Remember, cosine is x. Where is x negative? Well, the x-coordinates in quadrant 1 are positive, so it has to be that I'm in quadrant 2. So the answer here is quadrant 2. You can use Roman numerals, or 2 is fine for me. Okay, if you feel comfortable with these problems, then stop the video, go back and try and find the answers to the remaining 3 problems, and then come back and see how you did. All right, 6. Secant is negative. Secant is the reciprocal of cosine, and cosine is x. So where is x negative? Well, the x-coordinates of points that are negative would be quadrants 2 and 3. This tells us that cotangent is negative. So cotangent is x over y. Well, remember, x is already negative. So what kind of number should y be so when I divide, I get a negative cotangent? Well, y's got to be positive if I'm going to divide and get a negative cotangent value. So where's y positive? Well, not down here. Y's positive here. So I'm actually in quadrant 2 again. All right. Let's look at problem 7. Oh, what is that? That's tangent of theta. So this is tangent of theta. Some angle theta is positive. So if tangent of an angle is positive, I know tangent is y over x. So either both y and x are positive, quadrant 1, or both y and x are negative, quadrant 3. Because a negative y and a negative x would divide and give you a positive answer. Secant is x. Where is x negative? Of the two that I have checked, x is negative only down here in quadrant 3, not in quadrant 1. That's out. The answer is here. So we're in quadrant 3. Cosecant is positive. That means y is positive. Y is positive here and here. Cotangent, which is x over y, is positive. So if y is already positive, and if I want a positive answer when dividing, then that means x is also going to be positive. X will not be positive in quadrant 2. It's only positive in quadrant 1, so my answer is 1. So in this lesson, we had a couple of objectives. The main objective was finding the 6 trig values with the presentation of either an ordered pair or given one of the trig functions and another constraint, or given a linear function, plotting that, and finding a right triangle. Okay, and the other objective was just to find quadrants in which an angle lies. Okay. So let me go ahead and present the key. You can always pause, check your work. And push it up so you can see this middle problem that we did not find the trig values for. Okay, and then to conclude on the back, and pushing up one last time.